Hey guys, here we are, Chapter 16, Section 6, pushing on, right? Biomass energy. Real quickly, we're going to look at two different forms, if you will. Solid biomass and liquid biofuels. So, solid biomass. This is a potentially renewable resource. You know, it all depends if we plant back and grow it back quick enough. It does require large amounts of land, and if we exceed the replenishment rate, that produces a net gain of emissions of greenhouse gases. So in other words, if we do it so it's not sustainable, we take out more than we can put back, then we wind up with net CO2 gains. So some pluses, some minuses. Liquid biofuels. So solid biomass, we're cutting down a tree and burning it, you know, basics. Liquid biomass, this is where we are taking something and turning it into a form of alcohol, if you will, something that we can burn. It can lessen our dependence on oil, which can be good, but biofuel crops can degrade the soil and biodiversity and also increase emissions. So once again, as with anything, we've got a little bit of, both things to look at. Let's address biomass more specifically. This is just where we're taking plant materials and agricultural waste that can be burned for fuel. Now, this could be cow poop, cow dung. Boy, when we were in India, Nepal, that stuff was used for fuel all the time. You take the cow poop, stick it on the wall, kind of like the picture back here, you let it dry, and then you can take it down and then you can light it. So biomass, it doesn't matter if it's just plant, could be corn stalk, could be a tree, could be a stick, could be plant, or could be animal poop. Biomass, plant or agricultural waste that we can burn. Now we have biomass plantations, if you will. Now this is where we're putting fast growing trees and shrubs for repeated harvest, like a tree farm, if you will. But we're specifically planting things that will grow quickly so we can harvest them to use for fuel. We also get wood pellet production. Now this is sort of a newer industry, if you will. The idea is you take the plant waste stuff, sticks and stems, you turn into these little pellets. And then these pellets are used, kind of picture back here, in plants to make electricity. Now normally these pellets need to be made out of hardwood. So we don't want to go in and start really cutting down our hardwood forest to make pellets for electricity. But unfortunately, that is apparently happening. Theoretically, the people saying, well, no, it's only the tree waste, the sticks we find, but deforestation of the areas that we're pulling this from, we are seeing going up. And a lot of this is European countries that have these pellet biomass plants, but they're willing to buy the fuel in order to get the electricity. So this wood pellet production is pretty much shown to degrade our forest. Not such a good thing. So burning wood and other forms of biomass is going to produce CO2 and pollutant. You know, you're burning trees or stick. You know, just like in a campfire, you burn it, you get smoke, and it's releasing the CO2. Now really, if we're cutting the trees down and burning them, but they're being replaced at the same rate, the CO2, it's about the same. But if we take down more plants than are growing back, then we have a CO2 increase, right? Because plants are taking CO2 out of the air. So if you take plants, we're releasing the CO2 from them, but if we're putting more plants, they're taking it out. So it could be a net CO2, not a gain, not a loss. But if we're taking more plants than we're replacing, then we wind up with a net CO2 gain. So sort of depends on how you're looking at it and what is occurring. When we're talking about biomass, we just mean we're taking plant material or agricultural waste, could be from an animal, burning it for fuel. We could be cooking with it, we could be turning it into electricity. A lot of the world, they're just doing their cooking with it, cooking over fire still. And that's where a lot of our biomass, especially solid biomass, is going to. In less developed countries, a lot of their energy supply to cook their food is just biomass. They're burning corn stalks, they're burning cow poop, they're burning rice stalks, anything they can to cook their food, biomass. trade-offs, right? What are the advantages? What are the disadvantages? Well, advantages. It's widely available, all right? We're growing corn and then there's corn stalks. We're growing wheat and then there's wheat stalks. We have trees and the sticks and the limbs fall off. Boy, in my yard I'm picking up sticks all the time. So it's widely available. It's all over. Moderate cost. It's not that much to get a hold of the materials, especially if you're just looking to cook something, etc. It's a medium net energy. It doesn't take that much to get it grows back, so it's a medium net energy for what it takes to get it and the energy that I get out of it. Medium net energy is pretty good. There is no net CO2 increase if it's harvested, burned, and replanted sustainably. As long as we're not taking more than we're able to grow back, it's a net CO2 even. And plantations can help restore some of these degraded lands. We can use, if we're specifically growing in areas to harvest it from, plantations can actually help out, and then we can even restore lands that have been degraded. These are all good things. Disadvantages, it does tribute to deforestation. Once again, we're cutting it down to get fuel. We tend to get cut down more than we're replanting. If it's done right, it can be good, but that's just usually not the case. Clear cutting leads to a lot of erosion, water pollution, loss of wildlife, loss of habitat, the whole 9 yards. And when we come to using solid biomass, when we start doing this on a big scale, we start clear cutting and then we get rid of entire forests. It's just not unusual. And it's definitely a downside. It can open up ecosystems to invasive species. You cut down these habitats, we're back to HIP code, right? Habitat destruction, invasive species, climate change, the whole 9 yards. And there is an increase in CO2 emissions if it's harvested and burned unsustainably. And typically what we've seen with solid biomass fuel is it is normally not done sustainably. If it's done sustainably, it's a net even. If it's not, it winds up being a definitive loss. Let's talk liquid biofuels. So it's kind of biomass, but it's a liquid, so we usually refer to it as a biofuel. Typically, this is where we're growing something and turning it into alcohol, like ethanol. You go to the gas pumps here around Florida, and they all say with 10% ethanol. We're adding alcohol, typically in America made from corn, into our gasoline so that we're extending our fossil fuel use. Makes us less dependent on oil imports. Typically a good thing. And then we have biodiesel. So ethanol, typically in the United States from corn, Brazil, other places they do it from sugar. It just depends on what your main crops are. Biodiesel tends to come from vegetable oils like corn oil or olive oil, any kind of vegetable oil. We can turn that into a biodiesel. It's like diesel fuel, like typically what our trucks and many things run on. And the biofuel is really good because crops can be grown throughout the world. It doesn't dictate, do you have an oil reserve in your country or not? We can grow plants everywhere. There's no net increase of the CO2 in certain circumstances. Okay, once again, if it's done sustainably, we're taking the plants, but once again, a lot of times not done sustainably. It's easy to store and easy to transport. We already have all of the distribution in place to move oil, gasoline around. Ethanol, biodiesel really can be transported all the same, so we already have distribution networks in place. Now, Brazil makes their ethanol, as I mentioned before, from sugarcane residue. So they grow the sugarcane to get sugar, and they squish it out and to get the liquid to make sugar while you're left over with the cane stalk. That is what they're using. It's basically waste product to turn into their alcohol. It's a higher quality alcohol than from corn. Sugar is just a lot easier to turn it into the higher quality alcohol. So we get a medium net energy out of it. In 2017, just to put a date on it, 30% of the corn produced in the United States was used to make ethanol. 30% of all of our corn went to making ethanol, gasoline to go in our cars by intake. Well, that's 30% that's not going to go into people's stomachs for food, as 30% that's not going to go to feeding animals. So once again, it's a trade-off in what are we going to use the land for. Now, corn-based ethanol has a low net energy. We didn't do it out of corn. We can grow a lot more corn. We can grow a lot more corn in the United States. We grow some sugar cane in the U.S., but we can't grow, it's only certain areas grow sugar cane as well. Brazil grows a lot of sugar cane, so they take advantage of it. In the United States, we grow a lot of corn, so we use it for corn. Now, producing and burning coal-based ethanol adds about 20% more greenhouse gases than actually just burning gasoline. So we kind of think, ooh, it's from plant, that's better, but we actually have higher based CO2, well, not just CO2, but others, greenhouse gases burning corn. So just because it comes from the plant matter doesn't make it any better when it comes to greenhouse gas releasing. Also, growing corn takes an awful lot of water. Corn is a thirsty crop, very water dependent, and our ethanol distilleries produce very large volumes of wastewater. It just takes a lot of water to create it, and we get a lot of wastewater from it as well. We also have something that we call cellulosic ethanol. This is an alternative. This is made out of the inedible cellulose. Now, this is some grasses and other types of plant, not corn. These are grasses, they don't really require fertilizer, and they don't have to be replanted. They're perennials, they just keep coming back up anyway. However, this is still under research, if you will. We've shown that we can make it, but we can't really ramp up the scale of it yet, but it's a possibility. We can make our ethanol out of grasses instead of corn, less water waste, a good possibility. Also, we can use algae. We've done a lot of algae produces oil. It's just like any vegetable, right? We get vegetable oil, corn oil, olive oil. Well, we can get oil out of algae. And getting the oil out of the algae, we can turn it into a biofuel. A lot of times biodiesel is the route we go. Once again, we haven't really been able to make it economically feasible. More research into it, a few technological breaks along the way, and algae might be a source that we do. Algae can grow in almost any water supply, so it could be a strong source. But as always, let's take a look at these trade-offs, right? So specifically biofuel. It does reduce the CO2 emissions for some crops, not all. Corn, not so much, but sugar and maybe the algae, it could. It's a medium net energy for the biodiesel from oil palms. So it's just as a benefit, if we're talking about from palm oil, it's a medium net energy cost. Some of the others, it's kind of low. It's a medium net energy on ethanol from sugarcane. It's more of a low when it comes to corn, but it keeps us from being dependent on oil from other countries. Disadvantages. The fuel crops have to compete with food crops. And if we want to grow more to make oil, then it's going to make the food prices go higher. Once again, 30% of all of our corn was going into ethanol. Well, if we don't have enough, then it can make the food prices go up. And the food crops can also wind up being invasive species, depending on the country that you're in. So, ooh, let's start growing this, or let's start growing this particular grass. Well, it could be an invasive species. Once you bring something in, it gets out. It's a low net energy for corn ethanol and for biodiesel from soybeans. So once again, some of these we're getting a medium net energy, that's good. Corn and soybeans, we can do it, but it's kind of a low net energy cost. And also we get higher CO2 emissions, especially from corn, which is mainly what we're doing here in the United States. So biomass as a renewable. It's renewable because it comes back in a human lifespan. However, this is not really going to be the route we want to go when we start talking about truly getting ourselves on renewable energies, but it's one of the things in the mix, and it is renewable because when we run out of fossil fuels, they're gone, right? Well, come back next time and we will look at hydropower, but for now, that's it. We'll see you next time.